Welcome back to Brainlab Techies, guys. This is day 5 of our playlist, Complete Statistics for Data Science. So, in the previous video, we have talked about the first measurement of statistics, that is descriptive statistics, that is central tendency. We just have started the introduction of central tendency. Now, we already have seen in day 4 that three types of central tendency we have. Let's do a quick recap. Like, what is a central tendency? It's a single value representation of the entire data set. Now, what are the types of central tendency? We already have seen three measurements. One is mean, median, mode. And I have said that three measurements of central tendency we can use in different situation. Now, today we will be totally covering mean, where to use, how to use, what is mean, what is the formula of mean, those things we will be covering. And why we are learning this? Because this is what is very fundamental to understand data analytics and data science. Whenever you are going for machine learning pre-processing and all, there you will be using this. So that's why stay tuned for, and let's start the video, which is mean. Today's topic is mean. So let's go for a simple example. Like, let's suppose I have 5 students and their score. Now 5 students is having different scores. Like, out of 30, some of them, one of the students scored 10, 20, again 10, again 25, and then one student is already 30 out of 30 he scored. Now the thing is, if I tell you what is the central tendency of this small data set, what you will be doing? You will be telling the average. So how to, like, you already know how to calculate average. So what you exactly do? You will be doing like 10 plus 20 plus again 10 plus 25 plus 30. You will be adding them all and you will be dividing the entire value with this sum by 5, because 5 students are there. This is how you can calculate the average. So here the result you will be getting 19. Okay, so 19 is what? 19 is giving the idea about the entire community. What is the average score? So this is how you can simply calculate mean. So what is the formula then? This is how you can calculate. This is an example. Now just I am giving you the formula. What is the formula? If I go with some data points, let's take those data points as x1, x2, like this. I am telling you xn up to n means we have a number of data points, a number of data we have. Now, how to calculate? So here, just you have to add all this value, means x1 plus x2 dot dot up to xn we are adding. So this is what, whenever you are adding this n number of values, this is what you can write in shortcut way. This is summation, and as because you are starting from 1 to n, you can simply write like this: I equals to 1 to n. In most of the videos or whatever resources you are referring, you will be seeing this type of notation. So that's why I'm just simplifying the notation. This is how you can write the sum of n numbers. Now what you have to do, you have to divide this by 8. So simply what you can do, this is a sum, this is a sum. Now you have to divide. So what is the mean? Mean is basically can be written in this format, x bar. Whenever you are writing x bar means this is a mean. So what is the thing? You have to do sum divided by number of data, number of data. So what is the sum here? You can write this summation I equals to 1 to n xi divided by n, or simply what you can do, you can write like this: x bar equals to 1 by n summation I equals to 1 to n, I equals to 1 to n xi. So this is what your formula of mean. Now this is how you can calculate the mean. Now let me tell you, I'm just giving one more example. So let's suppose here 5 students we have, and now in this case we are calculating the age. Now if I tell the 5 students age, let's suppose the age varies from 21 22, after then again 21, again 23, and again 21. So from this, if I tell you what is the average age, so what you will be doing, simply 21 plus 22 plus 21 plus 23 plus 21. Now how many students now? 5 students. So simply you will be adding and divide. The result will be like, it will be close to 21 from here, as you, because as you can see here, 21, 21, 21 is the most repeated, so it will be close to 21. It is 21.6. This is the actual result. Now if I tell, let's do the average of 6%. Now this 6% is basically this 5 students is already there. Now you are adding their professor as well. Now the professor age is 47. Now professor age is 47. Now if I tell you to tell the idea about the entire station, how many person are there, what's the average age of the session, what like whoever audience are there. So I'm just asking you the average age of the persons present in the meeting. Okay, so 6 people present including the professor. This is the professor. Now for this case, if you are adding all the values like this, 21 plus 22 plus 21 plus 23 plus 21 plus 47, now you have to divide it with by 6. So what is the value now? So now here the value is showing 25.33, if I'm correct. 25.33, but do check it in the calculator. Okay, so 25.33. Now this is what is giving the idea about the entire session students or session person. Now this 25.33, is it a good representative of the entire community? Because is there anyone who is close to 25? If you see 23, it is there, but most of them are 21. So the average should be 21, because most of them are actually 21, but it is showing 25 because of the value 47, because here 47 present, because we are adding a very high value, that's why the average is also changing. Now this type of value, if we have a total data points where some of the values are not in the cluster, it's not following the cluster, those type of value is actually called outliers. Now in this calculation, from this calculation, I guess it is clear that how much outlier is affecting the mean. Like whenever you are going to understand the average or the idea about the central portion, it is totally deflecting because of the presence of this outlier. So outlier effect is there, and this is the biggest disadvantage of calculating mean as a part of central tendency. So central tendency is very much affected by outliers. If you have the data which is having lots of outliers, then obviously central tendency would be not a good choice as a, like mean is not a good choice as a central tendency measurements. So what is a outlier? Now let me tell you what is outlier. So a outlier is a data point which is very different from the rest of the data points. Means what? Like outlier is a value which can be too high or too low as compared to the data points. If I draw a diagrammatic presentation of outlier, you will be better understand. So from here, as you can see here, this is the entire data points. Now this is the value which is very high, and this is the value which is very low. Now these two value can be considered as outliers. Means this is too low and this is too high value. Now these two value are very different from the rest of the values. This value also more or less low value, correct? So these are all the outliers. Now outliers can be classified based on these values. Means if the value is too high, then outlier is called high outliers, and if it is the value is too low, then outlier will be considered as low outlier. So one is your high outlier, other one is your low outlier. This is how you can classify. Now, if both of them, like any of the outlier present, means mean will be getting affected. So for the presence of outlier, if we have outlier in our data, will not take mean as a central tendency measurements. For that we will be having for other options, means median is also there, mode is also, that thing you have to see for the next video. So as a conclusion, what I can say, so if there is any outlier present inside the dataset, it is not recommended to use mean as a central tendency measurement. So this is what the like disadvantage of mean. So in the next video we will be talking about median, and then we will be going for mode. So that's all for today. If you have any doubt, please let me know in the comment, and stay tuned guys. Thanks for watching. Bye bye, take care.